Okay, good morning. Welcome to
FamilyMath145.
on FamilyMath145. So I got this awesome book called Love and Math by Ed Frankel, who's a Russian mathematician who's at Berkeley now.
Cool.
He and I are about the same age. I think he's maybe like 4 or 5 years older than me, but he's a really famous mathematician. And this book is really cool. And yesterday I was reading about the square root of 2 and I, which we've actually talked about before.
Yeah.
About a month ago, maybe?
Maybe. Probably.
6 weeks ago, something like that. But I thought it'd be fun to revisit, just with some of the thoughts that Ed Frankel had. What can you tell me about the square root of 2?
It's irrational.
Square root of 2 is irrational, okay. Okay.
We can prove it by proof of contradiction.
Okay, how do you remember how that proof goes?
I think it's...
Well, the square root of 2 equals a over b.
Okay.
And a and b are in lowest terms.
All right. So we're gonna prove it's irrational by assuming that it's rational. So what are a and b here?
They're integers in lowest terms.
Integers in lowest terms. Good job. So like 3 over 2 or 9 over 10 or whatever it might be. Okay. All right. Drop them.
So now we can square both sides.
Okay.
2 is a squared over b squared.
2 is a squared over b squared. Okay, then that's just what this means.
Yeah.
Right? And why can we square both sides?
Because we can square both. It's just a over b squared, which is a squared.
Yeah, but why can we do that? Why does this equation allow us to do this equation?
Because we're doing the same thing to both sides.
Okay, they're equal. So if you do the same thing to both sides,
They're still equal.
it remains equal. Okay.
So now we've got 2 equals a squared over b squared.
Mm-hmm.
Then
What was the next thing in this proof by contradiction? How'd it go?
Well, I remember that we proved that a and b were both even.
Yeah, well, we didn't. We ended up showing a and b both had to be even if a squared over b squared was 2, but how did we do that?
Well, if you're squaring them, if you assume a and b are in lowest terms, but if you square them, they don't have like 3 and 3. If you square 3, it's 9.
Yeah. But if they're in lowest terms here, that means they don't have any common factors, right?
No.
Yeah.
So if you squaring just means multiplying by a over b again, so they won't have any common factors. Gotta see what the next step could be. Have any
Guesses?
any thoughts?
We could move the 2 to the other side. I'm not sure what that would do though.
Why would you want to move the 2 over here?
Well, it might help prove that a and b are even.
Okay. But that would make something that said 1 equals a squared over 2b squared.
That's probably not going to help us too much.
Do you think that's a more complicated expression or less complicated?
Probably a little more complicated.
Okay. That'd be great if we could make this expression less complicated.
We can multiply everything by b to get rid of the fractions.
Okay. What equation would you get next?
Multiply by b squared.
Yeah, what would you get next?
You get 2b squared.
2b squared equals
a squared.
Okay.
This proves that b has to, well, a is even.
Why is that?
Because you have 2 times a number is another number.
Okay, so we have an integer over here, and it's multiplied by 2, right?
Yeah, that means it gets...
That's the definition of even. So a has to be even.
yes.
Okay?
Yeah.
Alright.
So a is even.
So
now how do we prove that
b is even.
b...
Yeah.
Well,
Let's use the fact that a is even. A is even means it's 2 times something, right?
Yeah.
So let's call it 2m
Alright.
squared. So 2b squared equals 2m squared.
Well, we can say this is 4m squared.
Alright, so 2b squared equals 4m squared. Did you understand that? We were multiplying 2 squared, which is
2 squared is 4.
4, and m squared. Okay, now what?
Now we take a 2 out of each end. b squared
b squared equals
2m squared. But we said they're even.
What's even?
We said a and b are both even, but we said 2m was a.
Yeah. So that's what we meant when a was even, 2m. It's
Yeah,
2 times
but-
something.
This means B is even.
This means b is even. B is 2 times some integer.
But we said they were in lowest terms.
But we said they were in lowest terms.
Ugh.
Ah.
So now it's
we just keep
irrational.
repeating
Now
this
it's-
forever.
Now we've got a contradiction. We assumed it was rational, and we found that we made a mistake in that assumption. Okay, let's move on to the next one.
All right.